holistic understanding, like I was talking about earlier, the macro and the micro. The macro, you see a balloon expand or contract, or you feel hot or cold, and that's easy to understand. We can all understand that. But truly understanding how temperature is related to speed or pressure is related to the density of the collisions against the container's wall is something that's not always easy to understand. But with this application, students can use it and understand what happens at the microscopic level, and then in their lab work, they can understand what happens at the macroscopic level. So it's not meant to replace laboratories. It's meant to augment it and help students get a understanding of something that you can't really see or interact with at your day-to-day life. You can't look under a microscope and see the gas particles whizzing around. So the students then understand the macro and the micro, so the knowledge is bottom-up and top-down. So then they have that continuous line. They understand everything from the smallest level to the biggest level of how it works. And that's also something I encountered when I was programming the application. Because I had to understand, to take my ideas at the macro level, I want the application to do this or that, and how to translate it into code at the micro level that the computer understood. So through the course of this process, I found 3 things that made it a lot easier to program, and they're what I call the 3 pillars of good code. And that's terseness, simplicity, and modularity. What I mean by simplicity is not how efficiently something is executed, but how efficient it is to understand it. So a really convoluted path that might be faster isn't always worth it, because when other people have to see what you're doing and try to understand it, it's really hard to understand the convoluted path that may be faster or better by some metric that you use. So, as an example, and this is real code, this gives you the inverse square root of a number. It was used in a game, and it's really fast. I don't understand it. I don't think the programmers understand it. It's ridiculous. And then, if you have something like that, most people, even if they didn't fully understand how to program, you get a better sense. All right, this is returning the inverse of the square root. So this one might run a little slower. It might take a few more milliseconds or nanoseconds. But if you have to go through the code and try to figure out what somebody's doing, this is going to be a lot easier to understand than this. Terseness. Less stuff, less fluff. This room has a lot of stuff. There might be some really cool stuff in here. But there's a lot of stuff that I don't want to go through. Now this room, it has a lot less stuff, but each piece has a defined meaning. And so that allows you to express your ideas more succinctly. It's like writing an essay. I did this too as a freshman. I would just fill up pages with fluff when I had to write essays for English class. And they didn't read well. And now I'm learning to write more, just getting straight to the point. And so my essays are shorter, but they're more terse, and they read a lot better, because you're not having to muddle through all this fluff of me restating the same thing 5 times. Modularity. When you're creating something, you want to separate the components. It's kind of like surgery. If you need to replace somebody's heart, and then it's connected to every other organ, it's going to be really difficult to replace. So if you have things that are cleanly separated and cleanly defined, there's something that handles the sound, there's something that handles the images, something that handles the physics, then it's a lot easier to replace pieces. If I port my application to the iPhone and the iOS, it might need a different graphics library. And if my code's all tangled together, it's going to be a nightmare trying to replace it. But if they're cleanly separated, then it's a lot easier to just take it out and put something new in. So one of my favorite things about this independent study was that I was able to not only use chemistry, not only use computer science, but a wide variety of knowledge from my entire high school career. I used physics in figuring out how the collisions between the particles would resolve themselves.